Hi everyone, my name is Kamal Krishna and you are watching Economics TV. In this video, I am delving into Chapter 3 Computer Exercises from the book Introductory Econometrics by Jeffrey Wooldridge, and the chapter name is Multiple Regression Analysis Estimation, and I am using Google Colab. It is a free online coding platform for Python. You can use any other platform you like. Okay, so let's begin. First, install these necessary Python packages for this chapter. Pip install Woolridge, pip install statsmodels, install matplotlib, and then install seaborn. Then import these libraries as follows. Import Woolridge as woo, numpy as np, pandas as pd, matplotlib.pyplot as plt, statsmodels.formula.api as smf, and then in the last, import seaborn as sns. In the first question, we are using the dataset birth weight BWGHT. So in this question, we are estimating a model where birth weight is being explained by two variables: 6, that is number of cigarettes smoked during pregnancy, and family income. And there are three parts of this question. What is the most likely sign for beta 2? And do you think sex and family income are likely to be correlated? Explain why the correlation might be positive or negative. And in the third part, it says, now estimate the equation and with and without family income using the data in BWGHT. Report the results in equation form, including the sample size and R squared. Now the first part, what is the most likely sign for beta 2? So generally it has been observed that family income positively impacts the birth weight of a child, because with better family income, parents are more able to afford better food, better healthcare, better nutrition. Therefore, the most likely sign for beta 2 is a positive sign. Okay. Now, in the second part, do you think sex and family income are likely to be correlated? Well, what do you think? We will have to check it out practically. So, first load the data set birth weight bwgst equals to woo.data in the bracket bwgst. Now display the first few rows by using the command print bwgst.head. So here are the column names in the dataset. And for the summary statistics, you can also type bwgst.describe. Okay. Now moving to the second part of the question, for the correlation, type correlation equals to birth weight, the dataset name, then select this column sex and family income dot core function CORR, and then type dot ILOC in the square bracket 0, 1. I'm using this command ILOC to extract the exact value between 6 and family income. If I do not use this command, it will give me the whole correlation matrix. Okay, but I do not want the whole correlation matrix. I just want the specific correlation value between 6 and family income. And this command does that. It gives me the value present in the first row and second column. So correlation between birth weight and 6 is minus 0.17. Well, there can be many reasons for negative correlation between these two values, because with greater family income, uh, uh, parents with better family income are likely to be more educated, and therefore they may reduce the number of cigarettes smoked during pregnancy. Better educated families may avoid cigarettes during pregnancy. Therefore, there might be a negative. There can be this can be the reason for the negative correlation between these two values. For scatter plot between these two values, we have to use the package SNS, that is seaborn. Now type sns.scatterplot in this round bracket x. In the x-axis, we have to take the family income. So select the family income column from birth weight database, and for y-axis, we have to select the column 6 from the birth weight database. Then give the x label name family income, give the y label name cigarette smoked, and the title of the plot can be scatter plot of cigarette smoked versus family income, and then type plt.show to display the scatter plot. And you can see in the right hand side, this is a scatter plot of cigarette smoked versus family income. It looks very randomized because the correlation, although negative, is quite low. So that's why it looks quite random or haphazard way. So in the third part, we are regressing birth weight on 6 without family income first. So type a new model, model 1 equals to smm.ols. In the formula, type birth weight tilde 6. That is, birth weight is being explained by 6. And the dataset name is bwgst, then dot fit function. Print the model results by typing model1.summary. And you can see the intercept is 119 and the coefficient on 6 is minus 0.51. That is, number of cigarette smokes during pregnancy negatively impacts the birth weight. Now we have to regress birth weight on two variables, that is 6 plus family income. So create a model 2 equals to smm.ols. In the bracket, formula equals to birth weight tilde 6 plus fam income, and the dataset name is bwgst.fed. Then type the summary of this results by typing model2.summary. So this is the OLS regression results with cigarettes and family income. So in this case, intercept is 116. The coefficient on cigarettes is minus 0.46. It is lesser than before. And the family coefficient on family income is 0.09, which is positive, as we had predicted in the first part of the question. Now we have to compare coefficient on 6 in both models. So coefficient of 6 without family income is minus 0.51 and the coefficient of 6 with family income is minus 0.46. So it is lesser than before because we have included family income in this model. So family income explains a little part of the variation in the birth weight variable. That's why this coefficient becomes lesser than before. Okay, so family income also explains some of the variation. That's why this coefficient decreases when we include family income variable in the model. So we are done with this question. Let's move on to the next question. In the second question, we are using the dataset hprice1 to estimate the model price equals to price being explained by square feet and bedrooms. So there are 5 parts, there are 6 parts of the question. In the first part, it says write out the results in equation form. Second part says what is the estimated price, what is the estimated increase in price for a house with one more bedroom holding square footage constant. In the third part, it says what is the estimated increase in price for a house with an additional bedroom that is 140 square feet in size. And in the fourth part, it says what percentage of the variation in price is explained by square footage and number of bedrooms. In the fifth part, it says the first house in the sample has square feet equals to 2438 and bedrooms 4. Find the predicted selling price for this house from the OLS regression line. And in the last part, it says the actual selling price of the first house in the sample was $300,000. Find the residual for this house. First, load the data set by creating a data frame hprice equals to woo.data in the bracket hprice1. Display the first few rows of the data set by typing print hprice.head. So these are the columns in the data set. Now let's create a OLS regression model by typing model equals to smm.ols. Formula equals to price being explained by square foot plus bedrooms. Dataset name is hprice.fit function. So print the summary results by typing model1 model.summary. Extract the coefficients by typing beta 0, beta 1, beta 2 equals to model.params. So it automatically assigns chronologically. First, beta 0 gets assigned the value of intercept, beta 1 gets assigned the value on square feet, and beta 2 gets assigned the value on bedrooms. So estimated regression equation is price equals to minus 19.31 plus 0.12 for square foot plus 15.19 for bedrooms. So what is the estimated price increase for one more bedroom holding square foot constant? So it automatically means the coefficient on bedrooms. Okay, so this is the partial interpretation effect. Since we are using multiple regression analysis, Each and every coefficient represents a partial effect on the y variable, keeping every other variable constant. So the estimated price increase for an additional bedroom holding square foot constant is $15,190,000. Now the third part, it says what is the estimated price increase for an additional bedroom with 140 extra square feet. So create a new variable, increase underscore width underscore 140 square feet equals to beta 2 plus 140 into b1. So the estimated price increase for an additional bedroom with 140 square feet is $33,170,000. Now in the fourth part, it says what is the percentage of variation explained. So it means that we are looking into the r squared value. Create r underscore squared equal to model dot r squared into 100. Percentage of variation in price explained is 63.19%. It's quite high. It's good. The model explains much of the variation in the y variable. And fifth part, it says predicted price for the first house where square feet equals to 2438 and bedrooms is equal to 4. So create a variable f house, that is first house, equal to pd dot data frame, and then mention the specific square foot, that is 2438, and then mention the number of bedrooms 4, and then use this equation. Type predicted underscore price equals to model dot predict f house. So predicted price for the first house is $354,61000. Now residual for the first house, that is where actual price is $300,000, and in the previous part we saw that the predicted price for the first house is around $354,000. So let's create the residual. Residual is equal to actual price minus predicted price. So residual is minus $54,61000. The residual here is negative, suggesting that the buyer overpaid for the house. Okay, so we are done with this question. Let's move on to the next question. In the third question, we are using the dataset CEO Cell 2. It contains data on 177 chief executive officers and can be used to examine the effects of firm performance and on CEO salary. In the first part, it says estimate a model relating annual salary to firm sales and market value. Make the model of the constant elasticity variety for both independent variables. That means that we have to take the natural logarithm of every variable mentioned in the model. Second, it says add profits to the model from part first. Why can this variable not be included in logarithmic form? In the third part, it says add the variable CEO10 to the model, that is CEO tenure, to the model in part 2. What is the estimated percentage return for another year of CEO tenure? And in the fourth part, it says find the sample correlation coefficient between the variables log, market value, and profits. Are these variables highly correlated? Let's see that. First, load the dataset CEO cell equals to foo.data CEO cell 2. Display the first few rows of the dataset by typing print CEO cell.head. So these are the column names of the dataset. Now we have to estimate log regression model. So log salary is being explained by log sales and log market value. Create model 1 equals to smf.ols. In the formula, type L salary. You can see in the dataset there is a salary column and there is one more column called L salary. So this is the natural logarithm form of this column. Similarly, we have sales column here in this dataset, and we have L sales. This represents the natural logarithmic form of this column sales. So L salary is being explained by L sales plus L market value. Dataset name is CEO cell dot fit. Type print model1 dot summary. So here is the summary result of regression analysis. The intercept is 4.62 and the coefficient on L sales is 0.16 and the coefficient on L market value is 0.10. So both the variables positively impact the CEO's salary. And the estimated regression equation is as follows: log salary equals to 4.62 plus 0.16 log sales plus 0.10 log market value. In the second part, we are being told to add profits without log transformation. So just repeat the previous formula and add one more variable in the right hand side plus profits, type a dataset name cosl.fit and then print model2.summary. And you can look at this result. The coefficient on profits is also a positive number. So profits also positively impact CEO salary. Now profits cannot be log transformed because they may contain 0 or negative values, making log undefined. We can take natural logarithm of only positive numbers. Okay. So that's why, and profits can also sometimes be negative. So that's why we cannot take the log natural logarithmic form of positive profits. Now we have to look at the R squared value. Type R underscore squared underscore 2 equal to model 2 dot R squared multiplied by 100. So percentage of salary variation explained by firm performance variables is 29.93. It is quite less for 3 variables. 3 variables should be sufficient to explain more than 50% of the variation. However, here R squared value is only 29.93%. In the third part, we are being told to add CEO tenure to the model. So repeat the previous formula procedure and then just add one more variable on the right hand side by the name of CEO10 and then the dataset name is cosl.fit. So print the summary results. Here you can see the coefficient on CEO10 is also positive. So CEO tenure is also positively related with CEO salary. Except the coefficient for CEO tenure, beta 3 equals to model 3 dot params and the square bracket type CEO10 and then create a variable percentage underscore return equals to beta 3 multiplied by 100. So the estimated percentage increase in salary for one more year of CEO tenure is 1.17%. Now let's look at the correlation between log market value and profits. Type the variable correlation equals to CEO cell and then select the columns L market value and profits, then dot core function CORR and then type dot ILOC in the square bracket 0,1. Correlation between log market value and profits is 0.77. The variables are not highly correlated, so multicollinearity is not a major issue. If this correlation value have been higher than 0.9, then we would have concluded that yes, these variables are highly correlated. So multicollinearity is an issue in our dataset. However, this value is 0.77. So multicollinearity is not a major issue. Okay, so we are done with this question. Let's move on to the next question. Thanks for watching. If you found this helpful, don't forget to like the video and subscribe to the channel for more content like this. See you in the next one.